Hi Ryan, welcome back. If you want to support me, please just press like and subscribe. We have this situation in maths where we end up with this zero up here. And when people first invented this concept, all they invented was, for example, if you wrote 2 with a little 3, it meant 2 times 2 times 2. If I wrote 10 with a little 2, it meant I write 10 by 10. And it meant that we had calculations like this, or actually later on in a moment, algebra like this. I could write it in a shorter way. For example, if I had m times m times m times m, instead of writing that out all the time, if it's in your calculations, in real life, you can just write that in with a little 4, which is a great system. They just made up that system. Let's have a look at what it means. You can just talk about anything, which I already had written here. Anything divided by itself is 1. So how many times does 3 go into 3 once? How many times does 5 go into 5 once? And how many times, you can even talk about how many times does m go into itself. How many m's go into m? And it goes once. Now remember, m only just stands in place of a number. So for example, if that turned out to be 6, it'd be 6 divided by 6. And 6 divided by 6 is just 1. If it turned out to be 5, 5 divided by 5 is just 1. So we know it's going to be 1. But by the index laws, I can subtract the 3's. So we have a rule, when you're dividing, the bases stay the same, and you go 3 take 3 is 0. So if I write it that way, and I go, how many times does it go in itself, I get 1. If I write it that way, again, the same as before, but I subtract the 3's, I get 0. So what this tells us is that 2 to the 0 means 1. And I could go on and I can do, for example, 10 to the 4 divided by 10 to the 4. Anything divided by itself is 1. So 10 to the 4 is 10,000 divided by 10,000. I've made the numbers a bit big. So if I use the index laws, 4 take 4 is 0. So 10 to the 0 also means 1. Now just very quickly, because what we're doing is on this video, I'm actually in the algebra section. So I'm writing up here and we're doing index laws of algebra. So anything divided by itself has to be 1. If I use the index laws, y squared divided by y squared is y to the 0. And y to the 0 is 1. And it mucks a lot of people up and they think, why should it be? Well, there's why it should be. It has to be. We've got no choice other than doing that. So here's some simple questions we're going to go through. We know by the rule if you have something written with a 0 above it, it's 1. So 5 to the 0, 1. So 10 to the 0 is 1. Now here's where people get mucked up. We know that 2 to the 0 has to be 1. And we know that 3 to the 0 has to be 1. So altogether we've got 2. So a lot of people think, we've got everything to the 0, we can just write 1. No, it's an order of operations actually. If you go to BIMDAS or BOMDAS or whatever you call it, there's different ways of naming it. That's going to be done first. That 0 gets done first. 2 to the 0 is 1. 3 to the 0 is 1, and then you can add them together. If you come down to this one here, let's go to letters. Does the same apply to letters? Yes. Anything to the 0 is 1. Anything to the 0 is 1. Now here's the first one. I often put an asterisk beside it if you want to do that in your notes. It's helpful. The night before a test, I look at a lot of things when I was in school where I wrote an asterisk. And even when I was at uni, I did the same thing. This actually means 3 times m to the power of 0. M to the index of 0. So we know there's a multiply in there. So that means that the 0 is what I call sitting on. It's sitting on the m, it's not sitting on the 3. It's only affecting the m. So it's only affecting the m. We know to do indexes before we do multiplication. So m to the 0 is just 1, and we end up with just a 3. Bit crazy. So if I look at that, I just go, that's 3 times by 1. Don't have to think hard, just 3 times by 1. So down to this one here, if I wanted to think of it the quick way, I can just go 5 times by 1 times by y. So that part there is only sitting on the x, it's only affecting the x. So this little bit in the middle, this becomes a 1. So we've still got a 5 multiplied by the 1, and we've still got the y. So that actually simplifies just the 5y. So in the middle of calculations, these things happen to us. We don't mean for them to happen to us, but they happen. So this one is just 4 times by x times by y to the 0. Don't have to write that out if you're confident with it. So that y to the 0 is just going to become 4 times x times 1. So it doesn't affect the x, it only affects the y. It doesn't affect the 4. So now we've got 4x is 4 1s are 4, and then we just write the x and we don't have to write the times. If I write this one out, if I had numbers, for example, let's say that was 3 plus 4. So if I had 3 plus 4, and you calculate that first, so it's brackets first, so 3 plus 4 would be 7, we'd have 7 to the 0, and that's just 1. But we've got letters, but we still have to calculate those whatever they were first, we have to calculate, so that's just 1. So that's probably about as fiddly as we can get on this. But it's really simple if you look at it, the zeros count on there is 1. I want to go one more that I haven't thought about when I wrote the questions out. So if I had a 3x with a 0, the 0 is now sitting on everything. The 0 is sitting on everything, so everything becomes 1. The 0 is sitting on everything, so everything just becomes 1. I hope it helps. If it helps, let your friends know, spread the word. Thank you.